All right, so example two, right? Power function formulas. All right, and so in this example, we're going to be given three different statements, and we're going to be writing a power function to represent the statement below. Right, so for A, we have the pressure P of a gas is inversely proportional to its volume V, right? And so let's just go back to our definition so we can remind ourselves how a power function that is inversely proportional will look like, right? So it has this format: y is equal to k divided by x to the power of n, where y and x, right, are going to be the quantities that we are relating to one another. Okay, and so here, right, we have the pressure P of right. So we're relating the pressure to of a gas to its volume, right? So pressure, right, is going to be our output quantity, and volume is going to be our input quantity, right? So since it is inversely proportional, right? So I'm gonna do the one for A on the bottom here. So let's see, we have A. Oops, we have A. Right, so we know that a function that is inversely proportional follows this format: k divided by x to the power of p, right? And then in this case, our y is going to be the pressure p, right? K is still going to be k. That's our constant. We don't know what the value of it is just yet, right? And then our x to the power of p, right? That is our input quantity, and that is going to be represented by the variable v, right? So this is our formula to represent the first statement. Pressure is equal to K divided by V. All right, cool. Let's go to B. Right now for B, we have the work done in stretching a spring is directly proportional to the square of the distance d that it is stretched. All right, and so for a function, for a power function that is directly proportional, it to x, it follows this format: y is equal to k times x to the power of p. All right, and let's rewrite this using the variables of the quantities that we have for work and for distance. All right, and so when we rewrite this, work is going to be our output variable. So we're going to have the work is equal to k, right? And in this case, it says that we are directly proportional to the square of the distance, right? So distance is going to be our input variable, right? But it's going to be squared. And so this is going to be our formula. W is equal to K times D squared. All right. And last one, all right, for C, we have the distance d of an object away from a planet is inversely proportional to the square root of the gravitational force F that the planet exerts on the object. All right. So since it's inversely proportional, y is equal to k divided by x to the power of p. Right. So let's rewrite this using the right variables. Right. So our output variable is going to be distance. So we're going to have d is equal to, since we are inversely proportional, k is going to go here in my numerator, and then we're going to be divided by the square root of the gravitational force, right? So we're going to take the square root of the gravitational force F, and this is our formula. Cool.